Hi student, today I am teaching you the next topic of the different form of energy, that is kinetic energy. As you know that there are two forms of the mechanical energy. One is the potential energy, another is the kinetic energy. Now what is potential energy that I have told you? Those who have not know, you can go through my channel and you see what is the potential energy and the mathematical expression of potential energy and also the different form of the potential energy. So today I am teaching you kinetic energy. So what is kinetic energy? Kinetic energy means when the body remains in the state of motion, the energy possessed by the body is known as the kinetic energy. Whenever the body remains in the state of motion, then the energy possessed by the body is known as the kinetic energy. Therefore, I have written the definition, you may note it down. The energy possessed by a body by virtue of its motion is called the kinetic energy. That means whenever the body comes in the state of motion, then the energy of the body is known as the kinetic energy. That means the kinetic energy is found in the moving body, where the body is moving. Say for example, a fan is rotating, it is having the kinetic energy. A freely falling body, it is having the kinetic energy. A cyclist is moving on the road, it is having kinetic energy. A student is running on a road, it is having kinetic energy. So all these are the examples of the kinetic energy. See, what is the expression of kinetic energy? The mathematical expression of the kinetic energy is K is equal to half mv square. Here K is the symbol of the kinetic energy and m is the mass of the body, v is the square of the v is the velocity of the body. So therefore the expression of the kinetic energy K is equal to half mv square. Now let us derive the expression of kinetic energy, that is K is equal to half mv square. How can you derive this? So before that you understand this. Now how can you find the kinetic energy of a body? Suppose a body is moving. How can you find the kinetic energy of the body? Suppose this is a body which is moving along this direction. That means the motion is happening in this direction. Now since it is the moving body, then the energy is having here kinetic energy. How can you find kinetic energy? To find the kinetic energy, we have to apply one force onto the body in the opposite direction of the motion of the body. That is known as your opposing force or resistive force. Now when this force is acting in the opposite direction, suppose this is the direction of the motion, now we will apply the force along this direction. So what happened to the velocity of the body? The velocity of the body decreased, and due to this reason the uniform retardation of the body is produced, and at last the body will come into the state of rest. At that moment the amount of work done by the force to stop the motion of the body is the measure of the kinetic energy. So therefore the kinetic energy of a moving body is equal to the work done by the body before coming to rest. That means if the body is moving, before it come to rest, how much work it has done, that is the kinetic energy of the body. And in order to calculate this, we have to apply one force, one opposing force, one resistive force, which will be applied in the opposite direction of the motion of the body. Therefore the body will come into the rest position, or the velocity of the body will become zero. For that, what do you have to do? If you apply a force, then the body will cover some distance during that time, and the work done by this opposing force is the measure of the kinetic energy of the body. Let us derive the expression of kinetic energy, that is K is equal to half mv square. Just see the derivation, all of you. Suppose this is a body and which is moving along this direction. This is the motion of the body. Now suppose the mass of the body is m, and the body is moving with the velocity v. Velocity of the body is v, and say one force is applied onto the body in the opposite direction of the motion of the body, that I have told you. One resistive force is applied, say the force acting over here, and that is your opposing force. What type of force? Opposing force or the resistive force. And in the same time the uniform retardation is produced. Why the retardation is produced? Obviously, when the force is acting in the opposite direction of the motion of the body, the velocity of the body decreasing gradually, and at last it will become zero. Therefore, the body will come into the rest position. So, due to this reason, the acceleration which is produced by the force, that will become the negative acceleration, and this negative acceleration is known as retardation. So, the retardation caused is equals to A, and in the same time the distance covered by the body is S. So from this information now we'll derive K is equal to half mv square. So let us consider, once again I am saying you, let us consider a body of mass m moving with a velocity v. When an opposing force F is acting onto the body, then the retardation caused due to the force is A, and in the same time the distance covered by the body is S. So therefore the kinetic energy of the body is equals to, what is the kinetic energy? The work done by the retarding force or work done by the opposing force. So therefore kinetic energy of the body is equal to work done by the force. Now what is the nature of force? That is the opposing force or retarding force or resistive force. That implies, therefore we can write kinetic energy K is equals to, how can you find work done by the force? Work done W is equals to F into S. So write down F into S. This is your equation number 1. Now how can you find the value of F and S? We know from the Newton's second law of motion, F is equal to m into A. So now write down, we know F is equals to mass into acceleration. That is equation number 2. Again, how can you find this S from here? How can you find the value of S? S will be found from the equation of motion. Now from which equation of motion we will find? Let us see what are the information given to us. Here what is given? The initial velocity of the body is given v, because the body is moving with a velocity of v. I have told you before. So the initial velocity of the body u is equals to v. General initial velocity of the body is denoted by the symbol u. So u is equals to v. Now the final velocity of the body v is equals to 0, because the body is coming into the rest position. Therefore the final velocity is becoming 0. And here the acceleration produced A is equals to minus A, because here acceleration is the retardation I have told you. So A is equals to minus A, and the distance covered already I have given, that is your S, in the time when the force is acting onto the body. So from this information we will find the value of S. So from which equation of motion we can find the value of S? Obviously from the third equation of motion, that is v square is equals to u square plus 2as, we can find the value of S. So by using equation of motion, what is the equation of motion? That is v square is equals to u square plus 2as. That implies v is given over there 0, that is the final velocity. So 0 is equals to u is given v, so v plus v square plus 2as. Since it is the retardation, therefore it will become minus. minus 2as. The minus for retardation, it is not acceleration. Therefore, that implies now we can write 2as is equals to v square. That implies s is equals to v square divided by 2a. This is your equation number 3. Now substituting the value of f and s from equation 2 and 3 in equation 1, we get the value of the kinetic energy. Now substitute this value. So from equation 1, what do you know? What is equation 1? Write down that. From equation 1, k is equals to, now from equation 1 you have known that k is equals to f into s. That implies k is equals to f. F is given m into a into s. The value of s already you got, that is v square upon 2a. So you may write here v square, it is your v square upon 2a. Now here a is cancelled, therefore we are getting k is equals to half into m into v square. So this is the expression of the kinetic energy, that is k is equals to half into m into v square. So therefore you may write here kinetic energy k is equals to 1 by 2 into m stands for mass into v stands for velocity square. So this is the expression of the kinetic energy of the moving body. Now simply from here it is understandable that the kinetic energy of the body is directly proportional to the mass, and also it is directly proportional to the velocity, which means that when the mass of the body is increasing or mass of the body is becoming more, therefore the kinetic energy of the body become more. Why? Because the kinetic energy is directly proportional to mass. Now here you are seeing also kinetic energy is directly proportional to v square, velocity square, which means that if the velocity of the body is increasing, kinetic energy will increase. But how it will increase? It is becoming k is directly proportional to v square, which means that if the velocity of the body becomes double, the kinetic energy of the body becomes 4 times. It will be not double. Here k is directly proportional to mass, which means that if the mass of the body is double, then the kinetic energy of the body is double. But here in this equation, since kinetic energy is directly proportional to the v square, when velocity of the body is becoming double, kinetic energy becomes 4 times. In the same way, when the velocity of the body becomes triple, then the kinetic energy of the body becomes 9 times. It will be square of that. Square of 2, that means 4. Square of 3, that means 9. If the velocity becomes 4 times, final velocity of a body is becoming 4 times than the initial velocity. So therefore the kinetic energy will become how much times? 4 into 4, square of 4. So 4 into 4 is 16 times. Kinetic energy becomes 16 times. So this is how you will understand the relation between the kinetic energy and mass and also the velocity. Now we'll see what is the relationship between kinetic energy and momentum. So next topic, the relationship between kinetic energy and momentum. What is that? The relationship between kinetic energy and momentum. Now, what should be the relationship between kinetic energy and momentum, and why should they relate with each other? Is there any relationship between kinetic energy and momentum? Obviously, there is some relationship between kinetic energy and momentum. Now, what is kinetic energy? kinetic energy means when the body remains in the state of motion, the energy possessed by the body is the kinetic energy that I have told you. That means the energy contained or the energy present on a body due to its motion is the kinetic energy. What is momentum? Momentum means the amount of motion contained by a body is known as its momentum. The amount of motion. So in both the cases, in case of the kinetic energy and momentum, one thing remain common. What is that? Motion. Here the motion, moving body. If there is a moving body, then you can find the kinetic energy. So if it is a moving body, we can find the momentum. So one thing remain common, that is your motion. And the physical quantity which remain common in both the kinetic energy and the momentum will be, obviously mass will be there. Apart from that, the velocity. Therefore, the expression of the kinetic energy is half mv square, and the expression of the momentum, you know it before in class 9 maybe, that is P is equals to m into v. So now from these two relations we will derive how this kinetic energy is related to the momentum. Let's see this. We know kinetic energy K is equals to half m v square. That is your equation number 1. Now momentum P is equals to m into v. That implies from here we can find the value of v. So v is equals to p upon m. So this is your equation number 2. Now substitute the value of v from equation number 2 in equation number 1. What do you get? Let's see. So substitute v from equation 2 in equation 1. We get, what do you get? So write down the equation number 1. What is equation number 1? That is K is equals to half into m into v square. That is your equation number 1. That implies K is equals to 1 by 2 into m into v. In place of v, we write here p upon m. So p upon m whole square. So that is equal, that implies K is equals to 1 by 2 into m into p square by m square. Isn't it? So I am writing in this side. So that implies K is equals to, now m and 1m is cancelled over there. K is equals to, what are you getting here? P square divided by 2m. P square upon 2m. So this is how the kinetic energy and the momentum are related to each other. From this expression you are knowing that this kinetic energy is directly proportional to the square of the momentum, and the kinetic energy is inversely proportional to the mass of the body. Now from this expression you can also write down in the other way, P square is equals to 2mk. Therefore now we can have here P is equals to 2mk root over. So that means the momentum is equal to the square root of the kinetic energy. So momentum is directly proportional to the square root of the kinetic energy. Here kinetic energy is directly proportional to the square of the momentum, but momentum is directly proportional to the square root of the kinetic energy. That I have showed you. From here also you can find it out. Here I am showing you how you can see. So let us discuss some of the conceptual questions which will help you in the competitive examination and also in the board examination from this concept only. See over there, if suppose two bodies, one light body, suppose this is a light body and another body is there, this is a heavy body. So this body is your heavy body. So light body means what? The mass will be less. Heavy body means the mass will be more. If both the body are moving with the same momentum, then how the kinetic energy is related to each other? How can you find? See over there from the expression. One is light body, another is heavy body. We know that kinetic energy is inversely proportional to the mass. So obviously for the light body the mass will be less, and for the heavy body the mass will be more. And as kinetic energy is inversely proportional to the mass, therefore the light body will be having more kinetic energy, because kinetic energy is inversely proportional to the mass. Now see this in the derivation. How can you find that one? This I have told you from this expression, since the kinetic energy is inversely proportional to the mass. So let us find this is, say the mass of the light body you take over there, mass of light body, say small m, and mass of heavy body you take over there, capital M. Now we see, we will find the kinetic energy of the light body and the kinetic energy of the heavy body. Since it is given that the momentum is same, we are not changing the momentum, only we are changing the mass of the body. So now let's find kinetic energy of light body divided by kinetic energy of heavy body. So that is equals to, now the kinetic energy of the light body, what is the formula? P square divided by 2m. Here we will use small m, because for the light body we have taken mass as small m, divided by P square. P we are not changing because the momentum is the same. So P square divided by 2, here capital M. Capital M stands for heavy body. So that is equals to, now we are getting over there, P square divided by 2m into 2 capital M divided by P square. Now P square is cancelled, 2 is cancelled. So therefore we are getting over there m divided by, or capital M divided by small m. Since you know that, since here you know the capital M is greater than small m, because it is heavy body. Therefore now what we can have, see this relation, KL by KH we are getting, means kinetic energy of the light body divided by the kinetic energy of the heavy body, and we are getting at plus capital M divided by small m. Since capital M is greater than small m, then we can have here kinetic energy of the light body obviously is greater than the kinetic energy of the heavy body. So in this way you can show in the mathematical form how the kinetic energy of the light body is becoming more than the kinetic energy of the heavy body. Now another question I am asking, this is one question I discussed, another question I will discuss. Same, one is heavy body, another is the light body. If both are having the same kinetic energy, then how the momentum is related? Means both the body are having the same kinetic energy. In the previous case we have taken, both the body are having same momentum. Now I am taking, both the body are having same kinetic energy. Now how their momentum is related to each other? Let's see over there. We will find in the same way. In this way you can also understand, since P is equals to 2mk root over, that means the momentum is directly proportional to the root over of m, means mass. Root over of m means what? Square root of the mass. So therefore the momentum of the heavy body will be more than that of the momentum of the light body. That will show it how it will be coming, how the momentum of the heavy body is becoming more than that of the momentum of the light body. See over there. In the same way find, so momentum of the light body divided by momentum of the heavy body. Now you know momentum of the body is equals to 2mk. This expression you take. So that is 2 for the light body you have taken small m, k root over divided by here 2 capital M, k root over, because there will be no change of the k kinetic energy. Therefore kinetic energy same, and 2 is the numerical value. So we are keeping same only. That implies now this momentum of the light body divided by momentum of heavy body is equals to, what is happening over here, 2 will cancel, k will cancel, so we will get over there small m divided by capital M root over. So which shows that PL by PH is equals to small m divided by capital M. So since here you get small m is less than capital M, therefore what you get? Momentum of the light body obviously less than from momentum of the heavy body, that I have told you. And we are now showing how the momentum of the light body is becoming less than the momentum of the heavy body. Okay, so next we see that work energy theorem. Now what is work energy theorem? You know that if suppose a body is moving, suppose this is a body, it is moving along this direction. So the motion of the body is along this direction. It is the motion of the body. Now if we apply one force along the same direction, what happened to the motion of the body? Obviously the velocity of the body will increase. That means the body will move faster. Now why the body is moving faster? Who is making it? This force. This force is making the body to move fast. Now why this force is making? Because some work is done by the force on the moving body to move it faster. Now when the body is moving faster, then what is happening on the body? Obviously the kinetic energy of the body is increasing. When the body was moving with some particular type of velocity, some particular type of kinetic energy it was having. Now when the force is applied onto the body, the velocity of the body increases. So due to that reason, the kinetic energy of the body is increasing. And this is due to the work done by the force on the moving body in the direction of the motion of the body. And this is known as your work energy theorem. So therefore, you may note it down. Work energy theorem states that work done by a force on a moving body in the same direction is equal to increase in its kinetic energy. Means whenever you apply a force on a moving body and the force will be applied in the same direction of the motion, it increases the kinetic energy. This increase in kinetic energy is equal to work done by the force. This is known as work energy theorem. Let's prove this theorem. Means we have to show that the work done by this force is equal to the increase in the kinetic energy of the body. So let us see. Let us consider a body of mass m. Suppose this is the body. This is the body. The mass of the body is m. Now this is the mass, and the velocity of the body is the initial velocity of the body. Initially the body is moving with the velocity of say u, and when the force is acting onto the body in the direction of the motion, this is the direction of motion of the body, then at that moment what happened? The velocity of the body is increasing. So the final velocity, this is your initial velocity. Now the final velocity is becoming v. Say this is the final velocity, and due to the increase in velocity, one acceleration is produced by the force. Say the acceleration here is a, and in the same time the body covers a distance. Say body is going from here to here. So this is the final position of the body. So the body covers a distance as s. Distance is equals to s. So let us consider a body is moving with the initial velocity u, and when a force F is acting onto the body is moving with the increased velocity, that is v, and due to the force the acceleration produced is a, and the distance covered by the body is s. Now I have told you the work done by the force is equal to the increase in the kinetic energy. So let us find the work done by the force. Now work done by force. So the work done by force, that is W is equals to, what is the formula? Same, that is W is equals to F into S. F into S. This is your equation number 1. Now how can you find F and how can you find S? Again the same way how we have done the derivation of the kinetic energy. We know F is equals to, F is equals to m into a. This is your equation number 2. Again I will find the value of S. Again the value of S will be found from the equation of motion. Now for that, see what is given over there. Initial velocity is given u, final velocity is given v, acceleration is given a. We need to find S. So by using equation of motion, which is that v square is equals to u square plus 2as. That implies V square is remaining V square only. So V square is equals to U square plus 2AS. That implies 2AS is equals to V square minus U square. That implies S is equals to V square minus U square divided by 2A. That is your equation number 3. Now substitute the value of S from equation number 3 in equation number 1. What is equation number 1? W is equals to F into S. So see over there, I am writing in this side. Now the equation 1 is W is equals to F into S. That implies W is equals to F. The value of F we got already, that is M into A. So right here M into A into the value of S is V square minus U square divided by 2A. So it is V square minus U square divided by 2A. Now here A is cancelled. That implies we are getting here W, work done W is equals to half M V square minus U square. So that is equals to, now we can write here 1 by 2 M V square minus 1 by 2 M U square. This half M V square and half M U square is what? Obviously here the final velocity is connected, therefore this is the final kinetic energy, and here the initial velocity is connected, therefore it is the initial kinetic energy. So thus we may write here W is equals to final kinetic energy minus initial kinetic energy. So this is the proof of the work energy theorem. So I have told you what is work energy theorem. Work done by the force on a moving body in the same direction is equal to the increase in the kinetic energy. There is some increase in the kinetic energy. That is, if you subtract the initial kinetic energy from the final kinetic energy, you can find how much kinetic energy is increased. So which proves your work energy theorem. So next I will discuss the different form of the kinetic energy. Okay, so we'll see now the forms of the kinetic energy. Now there are three forms of the kinetic energy. What are these? These are translational kinetic energy, rotational kinetic energy and vibrational kinetic energy. Now it depends upon the motion of the body. Now if a body moves in a straight path, then the motion of the body is said to be translational motion. Therefore, the kinetic energy of the body is said to be translational kinetic energy. When a body moves in a straight path, see this is I have written also, when the body moves in a straight path, say for example, a freely falling body is having the translational kinetic energy. A boy is moving on a straight road is having the translational kinetic energy. So what is the example of the translational kinetic energy? The example of this will be a freely falling body. Freely falling body will be having the translational kinetic energy. Now next I will discuss about the rotational kinetic energy. When a body rotates about a point, then the motion of the body is said to be rotational motion. So at that moment the kinetic energy contained by a body is known as the rotational kinetic energy. That means whenever you see that the body is rotating about a point, then the kinetic energy of the body is the rotational kinetic energy. Say for example, the wheel of the bus, the wheel of the truck, the spinning top, and all these are the examples of the rotational kinetic energy. So what are the examples? That means rotation it is. Now the examples will be here spinning top. You can write here spinning top. All these this is the example of the rotational kinetic energy. Next, vibrational kinetic energy. Now what is vibrational motion? When a body moves to and fro about a mean position, then the motion of the body is known as vibratory motion or vibrational motion. Then at that moment the kinetic energy contained by the body is known as the vibrational kinetic energy. Say for example, if I bring a metallic strip and I clamp at one place, at the end, and to the another end I'll apply a little bit of force so that the metallic strip will move, will vibrate in this manner. Therefore, the kinetic energy possessed by that metallic strip will be your vibrational kinetic energy. Any vibratory body will be having the vibrational kinetic energy. The string of the guitar, the string of the sitar is having the vibrational kinetic energy. So all these are the translational, rotational and vibrational kinetic energy are the different three forms of the kinetic energy. So now I am discussing the conversion of the potential energy into the kinetic energy. Now what is that? The conversion of the potential energy into the kinetic energy. Can you say me? This is actually when a body is put into use. Whenever we are using our body, at that moment the potential energy of the body converts into the kinetic energy. Whenever the body is put to use, remember, when the body is put to use, the potential energy of the body converts into the kinetic energy. Say for example, if suppose a body is placed at a height, what type of energy the body is having? Suppose this is the conversion of potential energy into kinetic energy. This is the next topic. Conversion of potential energy into kinetic energy. Whenever the body is put to work, whenever the body is being used, whenever the body is put to use, then the potential energy of the body always convert into the kinetic energy. Say if suppose this is the ground, see over there, this is your ground, and one object is placed at this height. This is the object which is placed at this height above the ground. So what type of energy this object is having? This object is having your gravitational potential energy. But what it is doing? Nothing it is doing. No work is being done. Now whenever we are making it fall towards the earth's surface, at that moment what happened? This potential energy, initially it was having the potential energy. So whenever it falls, suppose now it is coming over here. Again after some time it is coming over here. Again after some time it reaches on the ground. Suppose on the ground if one nail is placed and it has to fall on the nail. Suppose it is coming and falling on the nail. Now what happened to the nail? The nail will penetrate on the ground. So initially this body was having the potential energy. Now whenever it is allowed to fall, this potential energy convert into the kinetic energy. Now this kinetic energy again convert into the kinetic energy of the nail. Therefore the nail is moving few centimeter on a wooden plank if it is placed on top of the wooden plank, or it is moving into the ground if it is kept on the ground. So this is how the potential energy always convert into the kinetic energy. Say another example I will give you. If suppose I will bring a spring. Say for example this is a spring. Are you seeing? This is the spring. So this spring is actually say it is the compressed spring. That means the force is applied onto the spring. In both the sides the force is applied. Therefore it is your compressed spring. Now at that moment what type of energy this spring is having? This spring is having your elastic potential energy. But what work it is doing? Nothing. No work is being done at this moment. Whenever we release the spring, whenever we are not applying that force onto the spring, then the spring will come into the state of motion. So therefore the elastic potential energy there convert into the kinetic energy. So initially this potential energy will be converting into kinetic energy. Again, if suppose you keep some of the papers on the spring, what happens to the paper bits? Those paper will be flying away. Why? Because this kinetic energy of the spring is also giving or converting into the kinetic energy of the paper. So therefore the paper is gaining the kinetic energy and they are flying away. So that is how the potential energy always convert into the kinetic energy whenever it is put to use. Whenever a body is put to use, the potential energy always convert into the kinetic energy. Another example I can give you. If suppose you bring a bow and arrow, you know bow and arrow. Suppose this is bow and arrow. Now, if I bring a bow and I just pull that, so what type of energy it is having? It is having the elastic potential energy. So at that moment, is there any work is done? No work is done. No work is being done. So whenever I am releasing my hand, at that moment the potential energy or the elastic potential energy of the bow convert into the kinetic energy of the arrow. So therefore the arrow is moving a few centimeter distance in the air. So that is how always the potential energy converts into kinetic energy whenever it is put into work. So now I will give you the difference between the kinetic energy and the potential energy. Let's see what is the difference between kinetic energy and potential energy. Both the form of the energy you now learn, so you may able to say me. Kinetic energy and then potential energy. Now what is kinetic energy? The energy of a body due to its motion is known as the kinetic energy. So the energy, you may note it down, energy of a body due to its motion, that is known as your kinetic energy. Now what is potential energy? That you know the definition of potential energy. What is that? The energy of a body due to its changed position or changed shape and size is known as the potential energy. So here it is what? Changed position or changed shape and size, that is known as your potential energy. Next, number 2. Now the kinetic energy of a body depends on the speed. Does the potential energy depend on speed? No. The potential energy of the body does not depend on the speed. So it depends on speed or velocity. Number 2, it does not depend on speed. Okay. Next, number 3. Now, how can you find the kinetic energy of a body? It is the amount of work done a moving body can do before it comes to the rest. That is how we will find the kinetic energy. Now, how can you find the potential energy? It is the amount of work done a force can do whenever the body is being converted or being come to the changed state is known as the potential energy. So this all about the difference between the kinetic energy and the potential energy. Thank you.